Hey guys, so today we're going to graph our third example of tangent and cotangent with transformations. This is a tough example. It really brings everything together. Every type of transformation we have is part of this problem. So first thing I would do always is I do y equals a, because this is our standard form. A, let me erase that so I can write tangent. A tangent bx minus c plus d. And a is our amplitude. B helps us figure out our period length. And period length, because it's a tangent, it's going to be pi divided by absolute value of B. C, that's our phase shift. So phase is also horizontal shift. And the formula for it is C divided by B. Then finally we have this D value on the end, which is our vertical shift. So that's like moving up and down. So now what I like to do is write down everything we have going on here. So first thing I notice is this negative. That's an x-axis reflection. We're going to have to do that before we do anything else. So we've got x-axis reflection right here. We've also got an amplitude of 3, because that's right in front of the tangent. And then we've got, okay, now let's work on our period length. So period length can be defined as pi divided by the absolute value of b. Well, our b in this case is just 2, so it's going to be pi over 2. Alright, now we have our phase shift, ps, and that can be defined as c over b. Our c, remember that the formula says bx minus c, so what we've done in this problem is that we've done 2x minus a negative pi to reach 2x plus pi. So that c value right there is negative pi. So c is negative pi divided by b, which we just said was 2. So our phase shift has been negative pi over 2. And then we've got a vertical shift, vs, we went up 1. So this is a lot of stuff right here. Now we need to make sure we keep track of it all. And let's just take a normal tangent and just try to imagine all these changes that are going to go on. Normally in tangent we've got an asymptote at pi over 2, negative pi over 2. Normally goes through the origin and it travels upwards, then downwards, and then does the same thing again and again. This next asymptote at 3 pi over 2, then it's going to do the same thing this way. So that's our normal tangent, and we've got some different things going on here. First, we've got an x-axis reflection, so immediately that's going to change all these lines. Let me erase them all. Instead of going up, they're going to start going down because we reflected over the x-axis. So everything's going to be going like this now. So that's it. And then we have an amplitude of 3. So what we do is we multiply this point, our important point, so which is 0, 0. We multiply it by 3. So we've got 0, 3 amplitude times 0, 0. That's just going to give us 0, 0. That point's not going to change. That's important. But what does change is all these other points, the line becomes steeper. A higher amplitude means a steeper line. Okay, so now we've got period length is pi over 2. So instead of right now the period, which is the distance between asymptotes for tangent and cotangent, is pi. So we're just kind of squish that a little bit. It's going to be pi over 2 now. Then phase shift is negative pi over 2. That means we went to the left pi over 2. So left pi over 2 units. So we'll have to keep track of that in our graph over here. Then up 1. Okay. So if we went up 1, just up the y-axis, that first point is now going to be 0, 1. Then now I have to think, okay, we also went left pi over 2. So it's going to be negative pi over 2 will be the new x value. 1 will be the new y value. And what I like to do is I kind of like to draw at 1. That's our new center line because we went up 1. So we can draw that in here. And we can draw our first point, which we just figured out was negative pi over 2, 1. Because we moved left pi over 2 and we went up 1. And then, okay, now let's start looking at this period length. The period length is pi over 2. So I know at halfway between, okay, so we've got pi over 4, and then negative pi over 4 is going to be an important point. And then negative 3 pi over 4 is also going to be an important point, because if the entire period has to be pi over 2, and we know that this point, that it touches the center line, is always in the middle of our period. So that's going to be an important point, and that means that these pi over 4s, they're going to be our asymptotes, because they have to kind of contain the graph. And then we also figured out that because we did an x-axis reflection, instead of going up, we're going down. So we're going to go down like this, and that 3 just makes it a bit steeper. So that's that one. And then, okay, next period, remember that we're going to have to go up pi over 2 units. And there's going to be an asymptote at the end. So if we started at negative pi over 4 and we went up pi over 2, we are now at pi over 4. We know that at 0, 0, because that's in the middle of pi over 4 and negative pi over 4, point is going to touch 1. So that's going to be the middle of our graph, and then we're going to travel down again. As you can see, this is going to start repeating, so we're going to go over pi over 2 again, draw in our asymptote. It's going to be pi over 4 plus pi over 2, which is 3 pi over 4. Again, we're going to have our midpoint, which is going to be at pi over 2, 1, and then it's going to travel down. So this right here is as hard as it can get. We can make sure we did everything. Did we reflect over the x-axis? Yes, it is now traveling down instead of up. Is our amplitude 3? Yes, it's steeper now. Did our period length change? Yes, now it's pi over 2 instead of pi. And did we move to the left pi over 2 units? Yes, instead of being at having our important point right at the middle, we moved it over pi over 2 and went up 1. So we had the phase shift negative pi over 2, and we also went up 1.